Okay, so hello everyone, this is Akshay here, and let us continue with today's question. So today's question is a good question here. It's a very good and standard question as well, asked in companies like Amazon and Microsoft, right, and Paytm and Zoho. So I hope you have read the question. The question is very simple. If you go with the brute force technique, that we have been given the array elements, right? The array length is given and a p range is given. P is nothing but it is indicating that your numbers would be present in 1 to n, right, which contains the integer 1 to p. Great. Your task is to count the frequency of all numbers from 1 to n, make it in place. In place means that we are not allowed to use any extra space. Do some changes in the given array and return the same array, right? Such that array of I equals to frequency of I. Okay. So for 23235, we can clearly see that the frequency of 2 is 2, and there are no ones present. So that is why at the first index, assuming the first index, one index, the first index is actually pointing to the value 1, which has frequency 0 in the given array element, so that's 0. Similarly for 2, there are two frequencies. 2 times it is the 2 is occurring twice, so that is why 2 is here. Similarly for 3, 3 is occurring twice, so that is why 2 is here. There is no 4 present here, so that's 0, and there is only single 5, so that's 1. I hope we are clear with the question, right? And having said that, the question is very simple. If you use a map or array to store the frequency thing, right, you just have to loop in using O of n to store the frequency and then just update your given array, right? But I'm showing the code for this as well. But if you're a beginner and you're not, if you're struggling with the brute force technique as well, then definitely you may not be aware of how to write the syntactical problem, right? Okay, so that's the code. If you use a hash map, so we have a hash map here, then we have a for loop. This get or default function is very important to remember. If you code in Java, it's very handy as well. And then we are just modifying our given array, right? Great, great. So let's just hit the submit button for this code. What is the time complexity? O of n. And let us analyze the constraint now. Constraint n is 10 power 5, which is less than 10 power 8. So even we are using a non-in-place approach, this code will get submitted, and because it is less than 10 power 8 iterations. I have not received any points, so that means I have definitely submitted this question in 2021. Great, yeah. So at that time, there was no third parameter, only array and the array and intent. There was no p, right? At that time, the question was that your elements would be present in the range 1 to n, but now here they have included a third parameter, that the question, the range of the given elements would be 1 to p, right? So in this code, we have not used p, right? We have just used the n. So let's leverage that p attribute or p parameter, right? So method 2 will take O of n, and that needs some explanation, and space const would be O of 1. Now I'm writing some bunch of operators, right? Please try to apprehend. Please try to understand. Go with the flow as I'm explaining, and you'll be able to make sense at last, or in the beginning, or in the flow as well, right? हम प्लस ऑपरेटर यूज करेंगे टू इंक्रीज द फ्रीक्वेंसी ऑफ अ गिवन एलिमेंट. मॉड्यूलर ऑपरेटर हम यूज करेंगे टू रिटेन द गिवन नंबर, एंड द डिवीजन टू रिटेन द एक्चुअल फ्रीक्वेंसी. ठीक है, तो होगा कैसे यार? वी हैव बीन गिवन एन एरे which has elements 2 3 2 3 and 5, which has index 1 0 1 2 3 and 4. Now the question has says that you need to do perform or return the frequency for one base indexing. Then definitely you need to perform 1 minus 1. You need to perform 1 minus 1, correct? Okay, 1 second. Okay, so it seems I was stuck with a Wi-Fi problem. So where were we? That we need to return the frequencies on one base indexing, right? So this 0 will become 1, 1 2, and then 3, and then 4 and 5. This is one base indexing, correct? So to handle this, we will do a minus 1. So let me just give a dry run, it will make sense to you, right? Okay, so for this 2, what we need to do यार कि ये जो 2 है, हमें इसके इंडेक्स पे, राइट, मतलब मैं डिफरेंट कर सकता हूँ, इस 2 का इंडेक्स कहाँ है? यहाँ पर, राइट, दिस 2. हमें इसके इंडेक्स को बताना है कि मुझे कैसा एलिमेंट एनकाउंटर हुआ है, एंड यू नीड टू इंक्रीज द फ्रीक्वेंसी बाय +1, right? Similarly this 3 will say कि अपने index पे जाओ, and I will say I have encountered element 3, you do +1 again, right? Similarly this 2 again, तो 2 के अपनी frequency पे वापस जाओ index पे and then do +1, so it would be +2. 3, so it would be +2 again. And similarly for 5, right? So this is the index, so you do +1 here, right? As you can see, your resultant array is nothing but 0, 2, 2, 0, 1, right? But how can we tell this without using an extra space? So let me write the elements again. So the elements here are 0, 2, 3, 2, 3, 5, and actual index are 0, 1, 2, 3, 4, right? And the index which I need to use is 1, 2, 3, 4, and 5, correct? So what did I said? We'll use a modulo operator to retain the given number, and we'll use a plus operator to increase the frequency, right? And to which number we'll be adding it with? We'll be adding with the given number, that is p. So just keep on listening, it will make sense to you, right? तो हम क्या करेंगे यार, हर एक नंबर के लिए हम एक इंडेक्स निकालेंगे. So index is nothing but your given number modulo of p. P is nothing, it's 5 here. I will do -1 to fix the indexing, right? So what does it say? It says you got a value as 1, right? We got a value as 1. We'll go to the first index, and I will say you need to increase your frequency because we have encountered element 2. हमें एक 2 मिला है और इस पोजीशन पे जो index 1 है, but actually this is an index 2 if you consider the 2 base indexing, and that is the reason we are handling it with -1. ठीक है, आप उस इंडेक्स पे जाओ, आप इसको किसी तरह बताओ कि मेरे को 2 मिला है, मेरे को +1 करना है. सो इंस्टेड ऑफ डूइंग +1 हियर, वी विल यूज द गिवन पैरामीटर p. I will do +5, right? So at the point of I equals to 0, our array elements will look like, so these are the index 0, 1, 2, 3, 4. Our array elements would look like 2, 8, 2, 3, and 5. Similarly for I equals to 1, I will again find the index, right? And index is nothing but, for I equals to 1, what is the element here? 8. But यहाँ पे actual element क्या था? यहाँ पे actual element 3 था, right? You can see here the actual element was 3. What I will do is, for increasing the frequency, I deliberately uses this p parameter, and I did +5. अगर मैंने किसी चीज में +5 किया है, right? ठीक है, और मैं चाहता हूँ कि ये जो x है, x प्लस p है, मैं चाहता हूँ कि मैं x को सिर्फ इसमें से निकाल पाऊँ, right? What I can do, I can take the modular operator of p. तो यहाँ पे क्या निकल के आएगा हमारे पास? x. So that's why I said to retain the given number that is given in the question, you will do a modulo operator. So I will do 8 modulo 5, again -1 to fix the indexing. So it would be 8 minus 5, definitely 3. 3 was our initial number, and 3 minus 1, which will give you as 2, right? So again, go to the 2 index. There is a second index, right? And like this one, right? And if you see the 1 base indexing, 1, 2, 3, 4, 5, यहीं पे हमें बढ़ाना भी था यार 3 के लिए. सब सही चल रहा है? ठीक है, ठीक है. So I hope you are clear. This is 1 based, this is 0 based. So I'm just writing it for you so that we can tally at each and every iteration. So 3 minus 2, again I need to increase the frequency for this particular index. तो मैं क्या बोलूँगा? Instead of +1, I will say +5. So our array elements will look like 2, 8, 7, 3, and 5, right? So we are done for I equals to 1. So let us solve for I equals to 2. Again we'll find the index. Index is nothing but, at index 2 the element is 7. So I will do 7% 5. Why %5 again? To retain the given element. So at this, the second index, what was the given element? 2, right? We can verify it from here. So 7% to 5 is 2, and 2 minus 1 to fix the indexing you'll get as 1, right? Correct? And you can clearly see if for this 2 we needed to do the plus operator as first index. ठीक है, तो हम again इसके plus पे जाएंगे, first index पे जाएंगे, element was 5, so I will again do +5, so it would be, I'll just say +5. What are the updated elements? It will be 2, 13, 7, 3, and 5, correct? Now for I equals to 3 again, I will again form the index. Y equals to 3. What is the element? Element is 0, 1, 2, 3. It is 3, right? So I will do 3 modulo 5 minus 1, which will give you as 2. So at 2 index, as second index, right? So this is the 0 based indexing. At the second index, the element present is 7. I will again do plus 5 here. So my array updated elements would be 2, 13, 12, 3 and 5. अगर आपको किसी पॉइंट पे कोई बात नहीं समझ में आ रही है वहीं पे पॉज करो, थोड़ा सा पीछे जाकर समझ में आ जाएगा. आई एम मेकिंग श्योर कि आपको ये बात समझ में आ रहा है. ठीक है. For I equals to 4, we'll again find the index. It is nothing but the element is 5, right? So 5% 5, and we'll do a minus 1, which will give you minus 1, right? But minus 1 index is not there, correct? So that means for a element, when an element if equals to p, we do not need to handle for this case, क्योंकि वो definitely अपने position पे होगा, correct? So we will have an extra if. So I am writing here, we will have an extra if statement for idx, which will check if it is greater than equals to 0 and n less than n, then only do these things. Which things? That array of idx plus equals to p, this thing, correct? Okay. Now at last, what are the elements? Let me write it. So 2, 13, 12, 3 and 5. Now to increase the frequency, we did it by 5, right? Plus 5, correct? And what in the multiples of 5, it has the multiples of 5 and some extra number, like this can be represented as 2 into 5 plus 5, right? Similarly, this can be represented as 3 plus 5 into 3, right? If I divide it by 5, I will be getting the frequencies. Can we do it? So let's dividing it by 5. 2 by 5 will give you 0, 13 by 5 will give you 2, 12 by 5 will give you 2, 3 by 5 again 0, 5 by 5 again 1. Can you see this was the answer? And I guess we are on a very better understanding that when and how and why we are using these three operators, right? I've tried my best here to explain you these things, and I hope you have a good idea. But there is one catch. So I have a second test case for you. Let's say for n equals to 4 and for p equals to 3, you have 3, 3, 3 and 3, right? So based on the above approach, if you do the same things again, so the indexes are 0, 1, 2, 3. So for this, the index you'd be getting will be 2, that is 3% 3. Okay, no, not 2, 3%. You'll be getting actually 3% 3 minus 1, which will give you as minus 1. So for all the elements, you will be not updating it, right? And at finally, and the final step was that divided by p, right? So if you divide by p again, what you will be getting? You will be 1, 1, 1 and 1, right? But ये आंसर है क्या यार? ये आंसर नहीं है. आंसर क्या होना चाहिए? Your final answer should look like the index 1 base indexing 0, 1, 2, 3, 4, and 3 is repeated 4 times. So it should be like this, 0, 0, 4, 0. Correct? So what we will do here is we will do extra work now, right? Instead of doing this with p, we will do with p++, right? ऐसा क्यों कर रहे हैं यार? क्योंकि देखो 3 को आप 3 से डिवाइड करो तो डेफिनेटली -1 आ जाएगा. बट अगर 3 को अगर एक बड़े नंबर से डिवाइड करो, 3 मॉड्यूलो 4 करो, तो क्या हम सेम नंबर को रिटेन कर पाएंगे जो हम बार बार कर रहे थे यार? अभी तक हमेशा हम %5 कर रहे थे, राइट? करेक्ट. बट अगर सारे नंबर्स ही ऐसे हैं तो उसके लिए तो हमें हैंडल करना पड़ेगा. तो हम क्या करेंगे? द सेम लॉजिक दैट वी विल बी रनिंग, that we were running for %p, we will be running for p++, right? So what would be the driver for this corner case? So p given was 3, I will go it for 4, right? The elements are 0, 1, 2, 3. This is the index. The elements are 3, 3, 3 and 3. So for I equals to 0, idx would be nothing but 3% 4 minus 1 to fix the indexing. So you get 2, and I will do what I was doing. I was doing plus p, right? And p is here is 4, so I will do 3 plus 4, 7. Now for I equals to 1, again The element is 3, so index would be again equals to 2. And I'll go to the index 2, I'll do plus 3 plus 4 again. So 7 plus 4 is 11. Now for I equals to 2, what is the element is here? 11% 4 minus 1. So it is 3. 3 minus 1 is 2. And you can clearly see what is 11% 4? It is 3. It is actually refraining or retaining the original elements here, 3. That was 3, right? Again, I'll do plus 4. So 11 plus 4 is 15. For the last iteration, for the last index, again the value is 3. So IDX would be pointing to 2 again. And I will again do 15 plus 4 is 19. What is your updated array? Can you write it for me? The updated array is 3, 3, 19 and 3. What was the, so this was the first step. What was the second step? That we were dividing it by p to get the frequency, right? Why? Because it is stored in x plus some y into p, and we know that this x is a frequency. We made sure that using this first operation. So if I want to delete this multiple y star p, then definitely I have to do divide with p so that we can get this x. Correct? Okay. What next? So 3 by 4 will give you 0. 3 by 4 will give you 0. 19 by 4 will give you 4. 3 by 4 will give you 0. So do we get the same answer as required one? Do we get the expected output? Yes. The question is solved now with all the dry run, right? Now it is up to you guys to please do some more dry runs, right? On this same particular question for rest of the cases. At least do one or more by yourself, and you'll be able to have a very good grasp that how it actually is working. And regarding our previous question in the bitwise where we expanded into 32-bit array, वहाँ पे मेरे को कमेंट्स आए थे कि भैया ये हो तो गया बट क्यों हुआ समझ नहीं आया, राइट? तो मैंने आपको वहाँ पे ही बोला था यार, अगर आपने बिटवाइज के स्टैंडर्ड क्वेश्चन कर रखे हैं, अगर बिटवाइज पढ़ोगे तो उससे बहुत सारे क्वेश्चन आएंगे जो उस तरह की सॉल्व होते हैं. तो ये क्वेश्चन जो आरे का है ना, ये भी कुछ वैसा ही क्वेश्चन है यार. जब भी आपको कोई ऐसा कोई क्वेश्चन मिले जहाँ पे मैप लगाने आ रहे हैं से आराम से काम हो जा रहा है फ्रीक्वेंसी वाला चीज़, बट वो चाहता है इनप्लेस करो आप, राइट? तो ज़रूर एक पैरामीटर ज़रूर होगा, या तो पी होगा और या तो इन माई प्रीवियस क्वेश्चन वेर आई हैड द सबमिशन, राइट, यहाँ पे पैरामीटर पी नहीं था, इंस्टेड द पैरामीटर इटसेल्फ वाज एन. द नंबर्स the range of the numbers were from 1 to n, and that is why it is the same logic written in some other manner, right? Okay, so that was the thing I wanted to say. Now please pause this video here, try to code this approach by yourself. We have discussed all the 2 steps. So this is the first step, right? Find the index, do this thing, and then at last run a for loop again and return, update your array with division of p. Great here. I hope you're able to code it now. Okay, so we had a p++. We have seen that why this thing is required to handle the corner cases. The corner cases is that the element, all the elements, let's say, is equals to, or one or more element is, let's say, equals to the given value p. We have a for loop, we found the index, and then we check if the index should be greater than 0 and less than n. Why we are checking? Because if the element is equals to p, then definitely we'll having the index as -1. So that's why we are checking it. If it is in the range, we are doing the operation, that is plus p. So this is nothing but that we are increasing the frequency. So let me write it here as well. We are increasing the frequency. We have just done a smart work that we are increasing it p times so that we can handle it. What we are handling, that we will be doing a modulo p for the next iterations to get the given element in the array. Correct? Okay, and that's it. So what is the time and space complexity? It is O of n as the time complexity, O of 2n, but ignoring the constant, it would be O of n. N is 10 power 5, that is we are using 10 power 5 iterations, so it is less than 10 power 8. It should definitely get submitted. And we have used O of 1 as space complexity, so definitely that's an in-place algorithm. And yes, that's it. So let us meet again in the tomorrow's streak. Till then, one last thing, there's the C++ code is the same thing we have done in Java and in the dry run. So let's just hit the submit button. You will get all the source code in my DSA repository. DSA repository link must be mentioned in my YouTube description. So let us meet again in the tomorrow's week, and till then, keep learning, keep growing. Bye bye, and take care, guys.